All right, let's talk about the brain. We're going to zoom way in on this one tiny part that most people have never even heard of. But here's the thing, it has a massive impact on our daily lives. I mean, it dictates how we move, what gets us out of bed in the morning, even how we learn. So, what is this tiny giant? Seriously, just think about it for a second. Every single move you make, reaching for your coffee, taking a step, even just fidgeting in your seat, it all has to get a green light from somewhere, right? Well, that's what we're diving into today, the brain's ultimate go signal. So, what is this crucial structure? It's called the Substantia Nigra. And you know what? Its name, well, it pretty much gives the game away. Okay, so picture the brain. Deep inside, right in the midbrain, you'll find this little structure. It's a major player in a whole network called the basal ganglia, which is basically the brain's movement control center. And the Substantia nigra? It's like the command hub for that whole operation, handling signals for everything from walking across the room to just feeling motivated. And the name itself is pretty cool, actually. Substantia nigra is just Latin for black substance. Simple as that. Why? Because when scientists first looked at it, they saw it was literally darker than all the tissue around it. And that dark color, that pigment, is a dead giveaway for what it does. It's a byproduct of its main job, making one of the most famous chemicals in the brain, dopamine. But here's where it gets interesting. This little black substance isn't just one blob. Nope, it's actually split into two different parts, and each one has a very specific and kind of opposite job to do. All right, so on one hand, you've got the pars compacta, or SNC. The easiest way to think of this? It's the dopamine factory. It is just jam-packed with those dark cells that are constantly churning out dopamine and sending it to the rest of the system. This is the go signal. Then, on the other hand, you have the pars reticulata, or SNR. This guy is the gatekeeper. It uses a different chemical, an inhibitory one called GABA, to send signals out. Its job is to filter everything, to stop or redirect any movements you don't want to make. So yeah, one part is the gas pedal, and the other is the brake and the steering. So let's really dig into that go signal. How does this one tiny spot kick off every single move we decide to make? It's like a perfectly choreographed dance of brain signals. Okay, here's how it goes down. Step 1, your cerebral cortex, the thinking part of your brain, decides, I'm going to pick up that glass. That's the plan. Step 2, that plan gets sent down to the basal ganglia for approval. And this is the magic moment. The pars compacta fires off a burst of dopamine. That dopamine is like the key in the ignition. It allows the system to filter out all the other random movements you could be making and lock in on just the one you want. Finally, that super refined green light signal gets shot through the thalamus and up to the motor cortex, which gives the final command to your muscles. And that's when you actually move. It happens in a flash, but it's a whole chain of command. So how does dopamine make everything so smooth? Well, it's pretty brilliant. It actually does two things at once. It hits the gas on what's called the direct pathway. That's what promotes movement. But at the exact same time, it slams the brakes on the indirect pathway, which is the part that stops movement. Think about that. By flooring the gas and easing off the brakes simultaneously, dopamine makes sure our actions are fluid and controlled, not all jerky and weird. Now, this system is amazing when it works, but it's also really, really delicate. So what happens when that signal starts to fail? When this perfect balance gets thrown off? Well, the fallout from that gives us a window into one of the most famous diseases of the brain. Right, so what happens when we start losing this crucial go signal? When that dopamine factory starts to shut down, production slows, and the consequences are huge. They're the defining features of a condition I'm sure you've heard of. And that condition is Parkinson's disease. At its core, that's what Parkinson's is. It's a disorder caused by the slow death of those exact dopamine-making neurons in the substantia nigra. And as those cells disappear, the brain's dopamine supply just tanks, and that all-important go signal for movement gets fainter and fainter. And this is what's absolutely wild. Get this. A person can lose up to 80%, 80 of the dopamine in this system before the major symptoms of Parkinson's even show up. I mean, for years, the brain is fighting behind the scenes, compensating, trying to make do with less and less, until it just hits a wall, a tipping point where it can't hide the problem anymore. Just amazing. And you can literally see the difference. In a healthy brain, that substantia nigra is dark and dense, pumping out dopamine, leading to smooth, easy movement. But in a brain with Parkinson's, it's faded. That dark substance is gone. And that's not just a change in color. That's the visible ghost of millions of dead neurons. And the result is a motor system that's become slow, stiff, and just struggles to get the go signal. This loss of dopamine directly leads to those classic Parkinson's symptoms. The brake pathway gets stuck on, which causes that slowness of movement. That's called bradykinesia. The lack of a smooth go signal, that's behind the tremors, the rigidity in the limbs, and the problems with balance. You can trace every single one of those issues right back to the failure of this one tiny part of the brain. But wait, there's more to this story. The Substantia Nigra isn't just about the pure mechanics of moving your body. That dopamine it produces, it's also the fuel for our motivation. It's the engine of wanting. This is such a key idea in neuroscience. People often think dopamine is the pleasure chemical, but that's not quite right. It's not about liking something. That's more the job of opioids in the brain. No, dopamine is about wanting something. It's the motivation, the drive that pushes you to go get the reward. It's what makes you seek out the things you need to survive, whether that's food, water, or even connecting with other people. And this role in wanting touches pretty much everything we do. The dopamine that comes from this area is what powers our motivation. It reinforces behaviors that work out for us. It's absolutely essential for forming habits, for learning from our mistakes. And on the flip side, it's the exact same system that gets hijacked when someone develops an addiction. So at the end of the day, you can think of this system as a really powerful teacher. When you do something and it has a good outcome, that little squirt of dopamine is your brain's way of saying, hey, pay attention, that worked, let's do that again. It's basically how we learn to be effective humans. So from something as simple as picking up a cup to the deep, burning drive to chase a dream, the Substantia Nigra is right there in the middle of it all, giving us the signal to both move and to want. The fact that it's so vulnerable in diseases like Parkinson's is just a huge reminder of the incredibly delicate chemical ballet going on inside our heads every second. It really makes you wonder, doesn't it? What other tiny giants are hiding in there, quietly shaping who we are?